My presentation is on aquatic systems and ecological pyramids. What are ecological pyramids? An ecological pyramid is a representation of the relationship between different organisms in an ecosystem. The bars in the pyramid each represent a different trophic level, such as primary producers, primary consumers, and secondary consumers, as well as tertiary consumers. Typically, an ecological pyramid will have 4 to 5 trophic levels. There are 3 major ecological pyramid types. The first one is the pyramid of energy. It represents the flow of energy through the trophic levels and the roles of each organism at different trophic levels. Typically, only 10% of energy moves up in the trophic levels. The other 90% is lost as heat. Here you can see the primary producers have the most energy, and they transfer 10% to the primary consumers and so on. The next pyramid is the pyramid of numbers. It is quite simple. It represents the number of individual organisms per unit area at each trophic level on the pyramid. Here you can see that the shrimp have the most and the osprey have the least. So as you move up, it decreases. The next pyramid is the pyramid of biomass. It represents the total mass of living or organic material present per unit area in organisms at each trophic level on the pyramid. This diagram shows the biomass pyramid of an ecosystem where the primary producer is grass and the tertiary consumer is a wolf. You can see that the biomass decreases as you move up the pyramid towards the wolf. In this diagram, it is the opposite. The biomass increases as you move towards the secondary consumer, which is a shark or a whale. Pyramids of numbers and energy are most often viewed as normal upright pyramids in all ecosystems. The pyramids of biomass are where marine ecosystems are viewed differently than other ecosystems. Biomass pyramids are often inverted or upside down for marine ecosystems. You can see in this diagram how the sharks and whales have the most biomass at 12 grams per meter, and the producers have the least at 4 grams per square meter. So why are they upside down? Biomass pyramids rely on the reproductive and longevity of trophic levels. In aquatic systems, primary producers such as phytoplankton have shorter longevity, leading them to have a smaller biomass count. Although they are consumed quickly, they rapidly replace their biomass, which means they can support the species that feed on them. The biomass of large predatory fish mostly outweigh the biomass of smaller fish at lower trophic levels. This creates an inverted shape to the pyramid where it is top-heavy. Another reason is because herbivores take more advantage of standing biomass such as plants than producers do. In aquatic systems, there are many examples of an inverted biomass pyramid. There are studies that show inverted pyramids in a range of communities, such as a kelp forest to sharks. I chose to focus on kelp forest communities. A study done by Rowan Trilopco and colleagues performed research on a kelp forest community where they used visual surveys to estimate the slope of a biomass spectrum to see if the fish community displayed an inverted biomass pyramid. The results showed a strong positive slope reflecting an inverted biomass pyramid. They surveyed a total of 203 transects and observed 4,537 fish between 32 and 2,048 grams. And the slope that they observed was 0.45. Although this does support an inverted biomass pyramid, it does not seem energetically possible as energy transfers would have to be extremely efficient. But as mentioned earlier, energy transfers usually do not exceed 10%. The movement, foraging, and aggregation of consumers across habitats may explain this match. In studies like this, it is extremely hard to account for movement, and the studies often depict a closed ecosystem. But it is important to remember that these ecosystems are energetically open. Although they are open, it is still quite clear that the biomass pyramids are inverted. Here you can see the positive slope, and this diagram reflects the inverted biomass pyramid. Interestingly, there are a number of factors that cause these inverted pyramids. In pristine coral reefs, causes of an inverted biomass pyramid may be due to immigration of prey, and as we saw earlier, in phytoplankton communities, phytoplankton reproduce at a high rate but do not have a long life compared to consumers. And at a biosphere reserve in French Polynesia, where 600 sharks live, the biomass pyramid is also inverted. This is due to the dietary needs and feeding behavior of the sharks. The sharks consume a lot of food to meet their needs and increase their biomass. The spawning aggregations of their prey also influence this inverted shape. The sharks' prey often spawn in clusters, which draws a high amount of sharks to the community. Here are my references.